So here is the countdown timer to the September 2018 equinox, and if you recall, back on the 14th of July, I first proposed the Equinox Challenge for September 2018 with the Nikon P1000 as the prize. Let's revise the contest requirements. For the Equinox Challenge, with a physical model, you must demonstrate 1. Why the equinox sun angles, sunrise, local noon and sunset do not work on a flat Earth, and 2. Why an equatorial mount polar aligned correctly cannot track the sun moving above a flat Earth from Sydney, Australia with a single axis of rotation. And to be clear, it must be a physical model. It must demonstrate both points fully. No CGI will be accepted and no drawings on paper. It must be a physical 3D model. And the contest will open when this countdown timer reaches 0, which is at the specific moment of the equinox. And it's important to understand what the equinox actually is. The September equinox marks the moment the sun crosses the celestial equator. That's the definition we are talking about, and specifically the center of the sun, because the geometry for the equinox is based on the center of the sun. And we'll talk about that a little bit more later in this video, because one of our flat Earth friends has recently made a couple of videos claiming to have found flaws in the equinox geometry. However, as you will see, what he has inadvertently done is provide further proof of the globe. As you see here, it states very clearly that it is not entirely equal day and night on the day of the equinox. On the two equinoxes, every year, the sun shines directly on the equator and the length of day and night is nearly equal, but not exactly. The precise moment of the equinox in September is Sunday the 23rd of September at 0154 UTC. You can convert that to your local time zone. This countdown timer is showing the date and time in New York time. So that's the 22nd of September at 9:54 p.m. So remember, the equinox is a specific moment in time. And the closing date for the contest will be the 1st of October, and I will be selecting 3 judges this week. In my original video, I asked for volunteers to judge the contest. I will select 3 judges, and they will be choosing the winner from the entries submitted. So as mentioned in my first video, the prize will be a Nikon Coolpix P1000, which has now been released, and we are starting to see some fabulous images taken with this camera. However, I will give the winner the option to take the P1000 or a cash equivalent prize of $1,000, which will obviously be converted to local currency if the prize winner is not from the USA. So good luck with the contest, and hopefully we see some entries from members of the Flat Earth community. So let's now take a look at this beautiful globe evidence that one of our Flat Earth friends has provided in his 2 recent videos. And those who follow my channel know that I generally don't target individual Flat Earthers, and nor do I mention their videos specifically on my channel. However, in this case, I'm going to make an exception because the evidence is so clearly in support of the globe. It was an opportunity too good to miss. So the Flat Earth gentleman who has kindly provided us with some superb globe evidence is none other than Mr. Antonio Subirats himself. Some of you may be familiar with his work, and the videos specifically are titled Flat Earth Embarrassing Equinox Problems and Equinox Punchline Flat Earth. So in order to understand why Antonio's videos provide evidence in support of the globe, we're going to revise some basic facts. Number 1, the equinox geometry is based on the center of the sun. The website Time and Date that Antonio uses determines the sunrise and sunset angles based on the top of the sun crossing the horizon. And that distinction is important. The equinox geometry is based on the center of the sun. Time and date measures the angles when the top of the sun crosses the horizon. And this is where the fun begins. Point number 3, at high latitudes, as demonstrated by Antonio, the sun moves sideways faster than it moves up and down when rising or setting. Specifically, the sun moves left when rising and setting in the southern hemisphere, and the sun moves right when rising and setting in the northern hemisphere. And I have personally verified in my videos many times point number 4, the sun moves left when rising and setting in the southern hemisphere. And here is an example of a sunset taken from Sydney, Australia. You can see as it is setting, it is also moving to the left. And that angle from vertical is matching the latitude of Sydney. And if we observe a sunset from a latitude further away from the equator, the angle is going to be flatter. It's going to be more horizontal. For example, at 60 degrees south latitude, the angle will be something like that. So the sun would actually be moving left faster than it is moving down as it sets. So let's take a look at it in a planetarium program, and this is Sky Safari Pro 6. I am on the day of the equinox, looking west at the equator. So it's just before sunset. Now remember, the equinox geometry is based on the center of the sun. Time and date reports the angles when the top of the sun crosses the horizon. It's currently showing 269 degrees, 53 minutes. So time and date would round that to 270 degrees. So let's take a look at what happens when we advance the time. And because we are on the equator here, the sun will be descending vertically, and therefore there will be no significant change in direction from when the center of the sun passes the horizon to when the top of the sun passes the horizon. Let's fast forward. There's the center of the sun. This is the reported angle of the sun, 269 degrees, 53 minutes. The site, time and date would round that to 270 degrees. Let's continue. There is the sunset, where the top of the sun crosses the horizon. Again, 269 degrees and 53 minutes, which would be rounded in time and date to show 270 degrees. All good so far. So I have now changed the location to Ushuaia in Argentina, which is one of the locations that Antonio uses on the day of the equinox. And a further relevant point is that the equinox geometry does not factor in refraction. However, the angles and the times of the sunrise and sunset on the time and date website do factor in refraction. It states that very clearly. Our sun calculator, which shows sunrise and sunset times in a location of your choice, takes the effect of refraction into account. So that is also going to result in further discrepancies between the angles and the true equinox geometry. So I currently have refraction turned off so that we can see the equinox geometry with the center of the sun crossing the horizon. You can see how close it is to west on the 22nd of September 2018, 7:25 p.m. local time in Argentina. Now, what happens if we turn on refraction? You can see that changes the apparent position of the sun. And if we now continue until the sun set, you can see how the sun is moving left. And by the time the top of the sun reaches the horizon, it is now 268 degrees, 54 minutes. So it's no longer being reported as 270 degrees on the time and date website. So due to the sideways movement of the sun at this high latitude, we're not going to see a direction of 270 degrees reported in the time and date website on the 22nd. In fact, we have to go 24 hours earlier to the 21st at sunset, when the top of the sun hits the horizon. We will now see time and date reporting that as 270 degrees. However, we are actually before the equinox, and so when the sun center crosses the horizon and you turn off refraction, you can see that we are well before the equinox. The center of the sun has not yet reached due west. And this is why the discrepancy occurs, because the time and date website measures the angle when the top of the sun crosses the horizon and also factors in refraction. The equinox geometry does not care about refraction and is based on the center of the sun. So I have now set the second location that Antonio mentions, Caniapiscau in Canada, still on the 21st of September, and refraction is turned off because we're going to look at the equinox geometry first. If we advance time, you can see the sun is now moving to the right as it sets. When the sun center crosses the horizon, the day before the equinox, you can see it is not at the west position. We have to move one day ahead to the 22nd. And as the sun center crosses the horizon, you can see that it is extremely close to directly west. Now that is the geometry of the equinox. If we look at how time and date would report that, we need to turn on refraction, and we need to move ahead. And you can see even on the 22nd, because of that sideways movement, by the time the top of the sun reaches the horizon, time and date would report that as 271 degrees. So we have to move another day ahead. Let's see how that works. Even still, the sun, when it sets, is going to be reported as 271 degrees in time and date, because it's 270 degrees, 37 minutes, which time and date would round up to 271. So we have to go another day ahead to the 24th. And there's the top of the sun on the 24th, and time and date would report that as 270 degrees. And this is precisely the discrepancy that Antonio has identified. In Ushuaia, the 270 degree sunset occurs on the 21st of September. In Caniapiscau, it occurs on the 24th of September. Now Antonio has incorrectly assumed that this is a problem for the equinox, but as we have just seen, it is confirmation of the globe, because the equinox geometry is based on the center of the sun without refraction. The time and date sun angles are based on the top of the sun and factor in refraction. And because of the differing movements of the sun in the northern and the southern hemisphere, in the southern hemisphere, the 270 degree sunset occurs before the moment of the equinox, and in the northern hemisphere, the 270 degree sunset occurs after the moment of the equinox. Exactly what we expect to see on the globe. So thank you very much, Antonio, for this wonderful evidence of our globe Earth. And for anyone interested in watching the videos, you can see that Antonio's point was that in Ushuaia, we see the 270 degree sunset on the 21st. In Caniapiscau, we see it on the 24th. As we have just demonstrated accurately, that is precisely what we should expect to see on the globe. So there's the punchline, Antonio. You have just confirmed the globe. And the part I find most amusing every time a flat earther produces evidence in support of the globe is how many other flat earthers just blindly praise the video without obviously understanding what they are watching. Here are some examples. Great find, shared. Acumen, Wolfie Sapien, shitting themselves. Well, I have to be honest, I almost did out of laughter when I watched the video. Great find. It's funny seeing the globies here pretending they know what the equinox actually is. Well, yeah, we actually do know what the equinox actually is, and that is why we know that it proves the Earth is a globe. It is very apparent that flat earthers still don't understand the geometry of the equinox. So for any of you flat earthers who praise this video, you should now go and hang your head in shame because this video supports the globe.